So, since you don't like doing math questions, here's some science questions. I'm going to try and give you a little of both, more math than science, obviously, but they both invoke problem solving. And if you can learn how to read tables, it'll help your math. Well, if you can learn how to put lots of things together, it'll help with math. I think the math and the science scores tend to mirror each other in some degree. ACT science, you've never seen any of it taught. Maybe some of it in physical science, but very unlikely. I mean, this is talking about power supplies and current and resistance. I don't think that's taught in high school, at least not in a traditional classroom. Anyways, we have some diagrams here. Figure 1 represents a circuit here. You got a power supply. You've got three components. You've got your resistor, your inductor, which they call L, and your capacitor C. And they've taken some measurements over it with an ohm meter, presumably. They tell you some things you may not know about electric current. It can flow through the circuit either clockwise, which is positive current, or counterclockwise, which is negative current. Now, I'm very removed from the ACT, but I think typically there tends to be a question about stuff like this somewhere where you see parentheses where they define things. So I might look for that first. And it shows how the current and the voltage in amperes, A, and the power supply voltage, V, per volts, both change during 20 millisecond time interval. So they talk about being positive. This would be clockwise. The current is moving clockwise. It's above the origin. It's positive. This would be negative. The current is below the x-axis. And there's multiple charts here involved too. Current is positive. Point of inflection, current is negative. Anyways, let's go back to this. I bet there's a question in here somewhere that deals with clockwise or counterclockwise. Polarity refers to whether a voltage is positive or negative. So a voltage of 0 volts has no polarity because it's 0. It's neither positive nor negative. Based on figures 2 and 3, which two voltages were always opposite polarity? So they're asking which two voltages is one of them positive and one of them's negative. So we got to make some comparisons here, and this is kind of what makes science tough. You've already been testing for 2.5 hours, and bam, you're tired, and here you got to go back and forth between tables and charts. So VR and VL. All right, VS is the dash. I'll label that for myself. VR and VL are over here. VR is the solid line. VL is the bigger of the dashes. So I'm supposed to compare and contrast VR and VL for polarity. That means that one of them's positive and one of them's negative. If you look at VL and VR, sometimes they're opposite polarity. Like right here is opposite polarity. All right. Right over in here is opposite polarity. But the reality is only sometimes. And they want the word always. Here is VR compared to VS. VS is over here. So, I got twice as hard. I'm looking at two different tables. So VR is positive all the way up till about positive all the way to 10 seconds. And VS is only negative up until about 3 seconds. So sometimes they have opposite polarity. I'm a little tongue-tied today, but I'm trying to do my best here. VL and VC. VC being all the dots. So here we have positive and negative. That's opposite. Positive and negative. We intersect. That's nice. Positive and negative. Positive and negative. Intersect. Positive, negative. They're always opposite polarity. Always. That one's H. So that wasn't too bad, I don't think. Anyways, I just did that one first because they define some words. A lot of times ACT likes to see if you can do something with the defined words. 23, according to figures 2 and 3, and this is one of the things that'll give you a headache on science, is you're looking at multiple tables at once. According to figures 2 and 3, which voltage varied the least during the 20 millisecond interval? So on one of these, I'll define the variation. Right here, we look to be at about a positive 250, I'm assuming microvolts. No, it's in volts. That's around 250 volts. With this being on the same dashed wave, negative 250. So if you look at VS, VS has about a 500 volt variance. So it's just high minus low, the difference between high and low values, okay? If you look at VR, the solid, it looks like we run from about 150 to about, I may not be 150, but anyways, it looks like around 300 volts. Probably less, maybe 280, somewhere in there, which it's high minus low. So I don't think it's VR. Then they mention on that question, they mention VL, which is this solid dash. And it's going to be this guy because it looks like it goes from about positive 50 to negative 50. It's only got about 100 voltages of variance. You can do the math on all of them, but it's choice C. We call that amplitude in mathematics. It has the least amplitude. 25, based on figure 2. I only got to look at one thing. You might do those first, the things that have you look at one thing. Based on figure 2, which of the following times was the current in the circuit flowing counterclockwise? Oh, so here's another one. Cool. I mentioned that here because I mentioned polarity. Did they actually define polarity? They did not, did they? Yeah, they did. Because they defined clockwise and stuff. All right. Anyways, there's the definition of counterclockwise. That means I'm looking for negative. I only have to look at figure 2. So where is the current negative based on the times? And that is going to be V sub S, the dashed. It is negative at 0. Five, it's not. 0 shouldn't actually be counted. That's kind of mean of them. At 10, it's positive. 15. Now, it's right there. Why shouldn't this be included? That is really mean of them. Why shouldn't I include that? That's technically negative. I guess because of the wave features of the graph here. I can't tell you why you should not be 0, but I do know the correct answer is 15. I guess maybe because you can't actually see what's happening before it, or maybe because literally no time has passed. That might have something to do with it. I don't know. I just don't know. But the answer is 15. 21, according to figure 2, thankfully only looking at figure 2, the maximum positive value, V sub S, was approximately. So I kind of highlighted it here. That's the maximum of V sub S. And then you just kind of run over here. I'm going to go with 250. Looks like 250. 275 would be closer to the top. A period is the time required for a wave to complete one full cycle. Based on figure 3, the period for V sub L, which is this guy. So if I follow V sub L, it rises to a peak and then it falls to a minimum. And that would represent one period. It's 20 milliseconds. 26, the table below lists the electric charge in microcoulombs, I'm not sure how you pronounce that one, stored on the capacitor at 3 different times during the 20 millisecond interval. Based on figures 2 and 3 from the time equals 7 through the time equals 13, did the charge on the capacitor more likely change in sync with I or V sub C, so with the current or the voltage? All right, so we've got from 7 to 13. I'm just going to block some stuff off. Now, before I actually go look at these things, I'm going to look at the time. Look at this thing. From 7 to 10, I am increasing. At least the charge is. And from 10 to 13, I am decreasing. So I'm actually looking for stuff that says increased and then decreased. Kind of look at the text. This says decreased, then increased, decreased, then increased. So the choice is between G and J. So over that time interval, I'm looking at G, over that time interval, both the charge and I increased and then decreased. So this is in figure 2. There's I, all right? From 7 to 13, the impedance did nothing but decreased. It did not increase, it went straight down. So it didn't do both. 7 talks about V sub C, which is in figure 3. Over that time, sorry, J talks about that one. Over that time interval, both the charge and V sub C increased and then decreased. So V sub C was my dots. Starts at 7. It is increasing. Whoop, you can't see my pencil. It is increasing, and then it is decreasing. So, choice J. There's the science, and I'm sorry I'm murdering it. Looking back at all those tables gives me a headache too. But I know those are the right answers. I know because I have a key. So, trust it. They're right. Try and make your own sense of it. Try and get into that college you want to get into.